Hey everyone, thanks for joining us for another session of our CISSP study group. I'm B-Dubs, and I couldn't be more excited to dive into today's material with you. Whether you're preparing for the CISSP exam or you're just enthusiastic about cybersecurity, you're exactly where you need to be. It's amazing to see your commitment to learning, and I can't wait to tackle these topics together. In our previous session, we explored Domain 2, Objectives 2.3, 2.4, and 2.5. If you weren't able to join us, then no worries. I've created a playlist for you to catch up at your own pace. Let me drop that link in chat now. Today we'll be finishing up Domain 2 with Exam Objective 2.6, Determine Data Security Controls and Compliance Requirements. This is a crucial area because let's face it, data is the foundation of any organization, and protecting it is so important. We're going to break this down in a way that's easy to understand and remember, so get ready to learn how to be data security superheroes. Remember, this domain is all about understanding how to protect your assets and data, no matter where it is or what's happening to it. Whether it's sitting on a server, flying across the internet, or being actively used by an application. We will also cover how to make sure we're following all the relevant rules and regulations, those compliance requirements that keep us out of trouble. Basically, we're learning how to be the guardians of our organization's most valuable asset, its data. Let's get to the foundation of everything, the three states of data. Think of data like water. It can exist in different states while remaining fundamentally the same substance. Just as water can be solid ice, flowing liquid, or vaporous steam, data exists in three key states: data at rest, data in transit, and data in use. Depending on the state of your data, it needs different types of protection, just like water needs different containers based on its current state. For example, when an email is sent, data is in transit. When you open a received file, that data is now in use. And when you save and close a document, it moves from in use back to stored data at rest. Understanding these states and transitions is crucial because each state requires its own unique security strategy. Just as you wouldn't store steam the same way you store ice, you can't protect data in transit the same way you protect data at rest. Data at rest refers to information stored within any type of storage media. Think of it like a sleeping giant. While not actively moving, this stored information represents some of your organization's most valuable assets. Think about your customer databases, financial records, intellectual property documents, files on hard drives, backups in the cloud, and even old tapes in archives collecting dust. The primary threats to data at rest include unauthorized access through cyber attacks, physical theft of storage devices, such as a stolen laptop, and insider threats from employees accessing data they should not have access to. Protection of data at rest requires multiple layers of security. Remember defense in depth here. Encryption is your primary defense. Modern standards like AES 256 for symmetric encryption and RSA for asymmetric encryption effectively create a virtually unbreakable safe around your data. Just remember, nothing is 100% secure or unbreakable, which is why we rely on our defense in depth practices. Key management with encryption is crucial. Your encryption keys must be securely stored and regularly rotated. Access controls determine who can decrypt and access the stored data. Following the principle of least privilege and need to know, only authorized personnel should have access to only the data necessary to complete their job, with all activities monitored and audited. Physical security measures like locked server rooms, security cameras, and proper hardware disposal all add yet another layer of defense to your defense in depth strategy. Backup strategies must include regular testing of restore capabilities. Your backups should not only be encrypted, but also stored in geographically separate locations. This protects us in situations where there might be an unexpected natural disaster or power outage, for example. When moving data to cloud storage, always encrypt it locally first. This ensures your data remains protected even if there's a security breach at the cloud provider level. And remember that regulatory requirements like GDPR may mandate specific protection measures for data at rest. Now, let's talk about data in transit. This is data that's on the move, actively traveling across the network, whether that's your internal network or the internet, or any other communication channels. Think of emails you send, websites you browse, files you transfer, or even those behind the scenes API calls you can't even see that your applications are making. The big risk here is someone intercepting that data while it's in motion, like eavesdropping on a phone call or intercepting a package in the mail. Data can be captured and compromised while moving between points. Man in the middle attacks, where someone secretly relays and possibly changes the communication between two parties, are a major concern here. That being said, we've got several tools in our arsenal to protect this data in transit. First, there's end to end encryption, which provides the highest level of security by encrypting data at its source and only decrypting it at its final destination. This is like sending a package in a locked box that only the recipient has the key to. The data is scrambled before it leaves your device and only unscrambled when it reaches its final destination. Applications like Signal and PGP encrypted email implement this approach. We also have link encryption, which is a little bit different, protecting data at each network segment. Think of it like each delivery truck in a chain of stops or hops having its own lockbox. This data is decrypted and re encrypted at each step along the way. This hides the routing information, or the information that shows exactly where the data is going, but the data itself is briefly vulnerable at each hop while it's unencrypted or unlocked. Service providers will often implement this method of link encryption. In fact, NIST Special Publication 800 12, which is an Introduction to Computer Security, the NIST handbook, specifically mentions that link encryption is often performed by service providers. For maximum security, we also have onion routing. This is the Fort Knox of data in transit. Think of the onion router, or Tor. This method wraps your data in multiple layers of encryption, like the layers of an onion. Each node or relay in the network only peels off one layer, revealing just enough information to send the data to the next node. The source and final destination remain completely hidden throughout this entire journey. It's incredibly secure, but it can be slower due to all that encryption and decryption. Additional protection measures also include HTTPS for secure web browsing, TLS SSL protocols for encrypted communications, as well as VPNs for creating secure tunnels through public networks. Finally, data in use is the most dynamic and, frankly, the trickiest data state to secure. This is data that's actively being processed by your computer. It's in your computer's memory, or RAM. It's in the CPU's registers. It's being manipulated by applications. Think of data in use like the engine of your car while it's running. All the parts are moving and working together. The threats here are very specific. Malicious code exploiting vulnerabilities in running applications. Someone trying to steal data directly from memory, also known as memory scraping. Or unauthorized users gaining access to sensitive data while it's being processed. Protecting data in use requires some advanced techniques. One fascinating approach is homomorphic encryption. This is mind bending stuff. It allows you to perform calculations on data while it remains encrypted. This is like a surgeon operating on a patient who's inside a completely sealed protective bubble. They can still do their work, but the patient is completely isolated from any external threats. Role based access control, or RBAC, is also essential here. It ensures users can only access the specific data they need for their specific job role, similar to how different security clearance levels work within classified environments. We also rely heavily on data loss prevention, or DLP, and digital rights protection, or DRP tools. These act like security guards, monitoring and controlling what users can do with sensitive data. For example, DLP might prevent copying classified information to USB drives, printing confidential documents, or sending these via email, while DRP extends this control by ensuring that even if data does leave your organization, it remains protected through encryption and access controls to limit actions like editing, forwarding, or even taking screenshots. Think of it like a document that can self destruct or lock itself if it falls into the wrong hands. And of course, never forget that protecting data in use requires a strong foundation. Keep your software patched regularly, run anti malware software, and ensure it stays up to date for the latest protections. And ensure you're following secure coding practices to minimize vulnerabilities from the very start. Now, we can't just throw every security control we know at every piece of data. That would be incredibly expensive, inefficient, and probably make it impossible to get any work done. Security controls need to be implemented strategically. This is where the concepts of scoping and tailoring become essential. We have to first scope and tailor our entire security approach. So, what is scoping and tailoring, and how do we utilize these concepts? Scoping is like drawing a boundary line. You're defining exactly what you're responsible for protecting. Scoping is about establishing clear boundaries for your security program. Then, you carefully define what systems, what data, and what processes are inside that boundary you established. This is your scope. Everything outside is, for the moment anyway, someone else's problem. Think of it like drawing a security perimeter. Anything inside this perimeter needs your protection, while elements outside can be managed by responsible parties. Tailoring is like getting a custom suit fitted. You start with a basic design, but then you adjust it to fit your specific body and style. Similarly, you can take the general security controls and customize them to fit your organization's unique needs, risk profile, and budget. For example, a small local bakery doesn't need the same level of security as a multinational bank or a government intelligence agency. Their risks are totally different, their resources are totally different, and their security controls should reflect that. The key is finding the right balance between security requirements and operational realities. Think of security standards as your organization's playbook for protecting data. These aren't just arbitrary rules, they're carefully designed frameworks, which are basically just a set of guidelines and best practices. These help you build and maintain a robust security program while also demonstrating that you're taking responsible steps to protect data. Following these standards doesn't just keep your auditors happy, it actually strengthens your security posture and helps prevent breaches. And don't forget that it's often a legal or contractual requirement to follow some of these standards. So, what happens if you don't follow these standards? The consequences can be severe, from hefty fines to legal action, damaged reputation, and lost business opportunities. That's why understanding and implementing the right standards is crucial for any security program. There are many different standards out there, but let's look at the major standards you really need to know. There's the GDPR, which stands for General Data Protection Regulation. This one is the gold standard for privacy protection in the EU. If you handle EU citizens' data, you need to know this one inside and out as it has very strict requirements for data protection and privacy. Then we have PCI DSS, or the Payment Card Industry Data Security Standard, which is essential for anyone who handles credit card information. It sets the standards for securely processing, storing, and transmitting payment card data. Now, did you notice how the PCI DSS specifically addresses this credit card data for each of the three states of that data? See, now you're learning. Everyone knows about NIST, the National Institute of Standards and Technology. Or if you don't, I promise you will. The multitude of NIST standards provide a wealth of guidance, particularly for U.S. government contractors or organizations working with the government. There are tons of NIST special publications, like NIST 853, which is their catalog of privacy and security controls. and NIST 800-171, which is designed to protect controlled, unclassified information, or CUI, in non federal information systems and organizations. These NIST standards are widely used as frameworks for building robust security programs, even outside of the government sector, as many private organizations use them because they're so comprehensive. And finally, we have to mention HIPAA, the Health Insurance Portability and Accountability Act. This is the set of standards that anyone in the healthcare industry in the US has to follow. Here's the key: you need to figure out which standards apply to your organization based on three main factors: your industry, where you operate, and what kind of data you handle. Then you build your security controls to match those requirements. Remember, this isn't a one size fits all situation. You need to scope and tailor your approach to your specific needs and requirements. Let's dive into some specific data protection methods. First, let's talk about DRM, or Digital Rights Management. This is a powerful technology designed to protect intellectual property. Think creative content like music, movies, software, ebooks, and even things like training materials. DRM controls how users can access and interact with this copyrighted material. Think of it as a sophisticated digital lock that stays with the content wherever it goes. DRM is everywhere in our daily lives. It prevents you from copying movies from your streaming services, limiting the number of devices you can use with your Netflix account, or controlling who can open and edit a sensitive company document. In the United States, the Digital Millennium Copyright Act, or DMCA, provides the legal framework for DRM, making it illegal to bypass these protections. While DRM focuses on commercial content, IRM specifically targets sensitive business documents. Using a combination of encryption and granular access controls, IRM allows organizations to maintain control over their documents even after they've been shared, restricting who can view, edit, print, or forward them. This persistent protection follows the document wherever it travels, ensuring sensitive information stays secure even when it leaves your network. DLP, on the other hand, or data loss prevention, acts as your organization's digital security guard. It's designed to detect and prevent sensitive data from leaking out, whether it's accidental or malicious. Think of it like having a security guard stationed at every possible exit point in your digital infrastructure, monitoring your email communications, your web uploads, USB ports, and even your printer activity, checking to make sure no confidential information is leaving without proper authorization. Now, what makes DLP systems particularly powerful is their intelligence. They use deep packet inspection to analyze not just the surface level information of network traffic, also known as the headers, but it's looking at the actual content that's being transmitted. They also use contextual analysis to examine multiple factors, looking at who is sending the data, what type of information it contains, where they're sending it, and when the transmission is occurring. All of this is managed from a central console, so security administrators can monitor all data movement across the organization in real time. For example, DLP can automatically prevent employees from emailing sensitive customer lists or databases to their personal Gmail accounts, stop them from uploading confidential design documents to a public Dropbox folder, or block them from copying proprietary code into a USB drive. It's a powerful tool for preventing data breaches and maintaining compliance with data protection regulations. In today's cloud first world, organizations are increasingly relying on cloud services like Salesforce, Office 365, AWS, and countless others. This shift creates new security challenges that traditional security tools weren't designed to handle, and we need a way to maintain security in this distributed environment. That's where CASBs come in. Think of them as your security traffic cops for the cloud. A CASB, or Cloud Access Security Broker, acts as a security checkpoint between your users and the cloud services they're using, making sure that everyone is following the rules. So, what makes a CASB so powerful? First, they give you complete visibility into your cloud environment. Want to know what cloud apps your employees are using? A CASB can show you everything, including those shadow IT applications that your IT team did not approve. Second, they help you enforce compliance by automatically applying your security policies and regulatory requirements across all cloud services. Third, they provide robust data security through encryption, access controls, and even DLP policies, protecting your sensitive information whether it's sitting in the cloud or moving between your services. Finally, they offer advanced threat protection, constantly monitoring for suspicious activities like unusual login patterns, potential data breaches, or malware that might try to sneak in through cloud applications. Obfuscation is a powerful technique that transforms sensitive data into formats that cannot be understood or accessed by anyone who shouldn't be seeing it. It's like scrambling the letters in a word so it becomes meaningless or blurring out a face in a photo. There are various ways to achieve this, depending on the context and the level of security needed. Let's start with concealing data. This is like having a secret room that only certain people know exists. This is making certain database fields completely invisible to specific user roles, not just restricting access, they won't even know these fields exist, providing the highest level of security through complete invisibility. Next, we have information and data pruning. This is useful in testing environments. You might take a production database, remove all the real customer information, but keep the empty fields visible. It's like having the blueprint of a building without showing who works in each office. Data fabrication is where we get really creative. Instead of using real sensitive data, we create fake data that looks and feels like the real data, maintaining the correct format and structure. This allows your development team to test everything thoroughly without risking actual customer information. It's like using Monopoly money to practice running a cash register. Data trimming is something you probably see every day. After you make a purchase and look at your receipt, you may see a bunch of stars followed by the last four digits. That's data trimming in action. This technique reveals just enough information for legitimate business purposes while protecting the rest. By showing only the last four digits of a credit card number, we leave enough to verify the card, but not enough to misuse the card for fraudulent transactions. We show just enough information to be useful, but not enough to be dangerous. Finally, let's talk about data encryption, the heavyweight champion of data protection. This transforms your sensitive data into unreadable code that only authorized users with the correct key can decode. And you can apply this at different levels. You might encrypt just one field, like all your social security numbers, or even your whole database for maximum security. The level of encryption you choose depends on how sensitive your data is and how much processing power you can spare, since the more you encrypt, the more processing power you will need. Now let's bring all of these concepts together with a concrete example. Imagine you're designing security for a healthcare provider. This could be a hospital, clinic, or a doctor's office. Their mission is to protect PHI, or protected health information, which includes everything from medical histories to insurance details and social security numbers. This is the perfect example because healthcare data needs some of the strongest protection out there. So, what might make this challenging? Healthcare providers have several key requirements. First, they absolutely must comply with HIPAA regulations, which sets strict rules here for handling PHI. There's no wiggle room. They need rock solid security for data in all three states: data at rest, data in transit, and data in use. Plus, they need to prevent against both external threats and potential internal misuse of data. So, how can they achieve this? For data at rest, they would encrypt all their patient databases and backups using a strong encryption algorithm like AES 256. They would also implement strict access controls, both physical, like security badges, and digital, like strong passwords and multi factor authentication, or MFA. for anyone trying to access these servers. For data in transit, anytime patient data is moving, like when communicating with insurance companies or allowing patients to access their records online, they would use TLS SSL to encrypt the communication channels. This protects everything moving between the systems. Nothing moves without encryption. For data in use, they'd set up role based access control, or RBAC, like giving different keys to different staff members. For example, a doctor needs full access to their patient records, but a receptionist only needs to see appointment details and contact information. They would also use a DLP system to monitor and prevent unauthorized actions, like stopping just anyone from copying PHI to a USB drive or sending unencrypted patient data through email. To tie all of this together, they would, of course, adhere to all HIPAA regulations and follow the NIST guidelines for protecting health information. And finally, they'd conduct regular security audits to identify vulnerabilities before they become problems and provide ongoing training to their employees on HIPAA compliance and data security best practices. It's a multi layered approach because protecting sensitive data requires constant vigilance. Remember, security is only as strong as your weakest link, and in healthcare or anywhere, that usually comes down to human behavior. Let's talk about some real challenges organizations face when implementing data security. While security is crucial, there are four major hurdles that security teams have to overcome. First, we have resource constraints. Nearly every organization struggles with this. You might have a limited budget for security tools, making it hard to get the latest and greatest solutions. You might also have a shortage of skilled security personnel. Finding and keeping good talent is not easy, and this talent also costs money, eating into the budgets. Plus, you're often competing with other business initiatives for IT resources, and those ongoing maintenance costs for security controls can really add up. The second challenge is technical complexity. Many organizations are dealing with legacy systems that just weren't built with modern security in mind. You might have a hybrid environment with some systems in the cloud and others on premises. Then there's the challenge of securing different technology platforms, all while trying to balance strong encryption and system performance. Third, we're facing evolving threats. The threat landscape is constantly changing, and it requires constant attention. New attack vectors pop up every time there's an advance in technology. The bad actors are getting more sophisticated, and we need to keep our security measures updated to stay ahead of these threats. Finally, there's the human factor. This might actually be the toughest challenge of all. People naturally resist security measures that slow down their work. They have established habits that are hard to break, and they get frustrated with additional security steps. Keeping everyone security aware and vigilant is an ongoing challenge. So, how do we handle all of this? Well, it requires a balanced approach. Here's what successful organizations might do. They start by focusing on their most critical assets. You can't protect everything equally, so protect what matters most first. They roll out security measures in phases. Trying to do everything at once is a recipe for failure. They invest heavily in user education and change management because security is everyone's responsibility, and they regularly evaluate and adjust their controls because security is never done, it's always evolving. And that brings us to the end of our deep dive into data security controls and compliance. But remember, protecting data isn't just a checkbox, it's an ongoing journey that requires constant attention and adaptation. So here's your mission, should you choose to accept it. First, take time to really understand the three data states we discussed. Each state, data at rest, data in transit, and data in use, faces unique challenges and needs specific protections. Think about real world scenarios where you might encounter each state in your organization. Make sure you understand the threats and appropriate controls for each one. Next, review those key standards we discussed, like GDPR, PCI DSS, NIST, and HIPAA. But you don't have to memorize them. Consider how they interact and overlap and why an organization might need to comply with multiple standards at once. Think about how they might apply to different organizations. Finally, get hands on with the security tools we covered and practice applying the concepts of scoping and tailoring. Understanding DRM, DLP, CASBs, and obfuscation isn't just about theory, it's about knowing when and how to apply them effectively. All right, not only does that wrap up today's topics on exam objectives 2.6, but this also completed domain 2. You did it! Progress is still progress, and we're taking these baby steps together. Remember, you can always go back and rewatch sections, pause, and take notes. These sessions will remain on YouTube, so you can come back and watch them anytime. I'm also adding chapters after each live stream so you can revisit certain topics. Keep studying, keep practicing, keep asking questions, and remember, if you're just getting started on this journey, every security professional started exactly where you are now. You've got this. Now it's time to start the after party. Join us in the Study GRC Discord server's CISSP voice channel for deeper discussions and to answer any questions you have. This is your chance to learn from others and build connections in the security community. If you're not in the Discord yet, you can go to cissp.britwhite.io for the Discord link. And don't forget to grab your CISSP role when you join. That way you can find the dedicated channels. Next time, we'll be moving into Domain 3, which is all about security architecture and engineering, during our live session on Tuesday, April 1st at 6 p.m. Central US time. And I promise you, this is not an April Fool's joke.